Hello, physics class. The first thing I want to talk about today is centripetal force and friction. Okay, I want you to know that centripetal force is not a fundamental force. You don't need to know about fundamental forces. There are 4 of them. 2 of them you'd be familiar with are gravitation and then an electric or magnetic force. Okay, those are forces that exist on their own. So we know about gravitation. Any 2 masses exert an attractive force on each other. For electric forces, any 2 charges either attract or repel. Same with magnetic poles, they either attract or repel without any help. But centripetal force isn't like that. Centripetal force is whatever force that's causing an object to move in a circle. Okay? So the force that causes something to move in a circle is the centripetal force. And for a vehicle making a turn, so I've got a little drawing here. It's supposed to be a top view of a car. So if it's going to turn in this circular arc, it's friction between the tires and the road that allow that to happen. Okay? That means that friction is the centripetal force for this car making this turn. Okay? So we write that friction is equal to the centripetal force, but what I really want to stress is that they're the same. These aren't 2 forces equal to each other. Friction is the centripetal force. Okay? If there was no friction between the tires and the road, this thing couldn't turn. It would just keep going straight. Okay? This is our formula for friction on a flat surface. Okay, and we're always going to assume a road is flat. We'll never get into banked curves, which is interesting physics. I invite you to do a bit of research on that, but you don't need to. And this is our formula for centripetal force we saw yesterday. That's going to lead into an example I want to show you on the back. Okay, so I want us to determine the maximum speed at which a car can safely navigate a curve with this radius of 50 meters. First, we're going to say the pavement is dry, and mu, the coefficient of friction, is going to be 0.6. So we know that friction is the centripetal force here, just like what we saw on the other side of this page. I'm going to set it up like this. And you'll notice I didn't give you a mass in the question, and that's because you don't need it. Which is good. If you were a civil engineer designing highways, you wouldn't want to need to consider every mass of every vehicle going through. There are considerations to take into account, but at the very simple level of centripetal force and friction, the mass is not a consideration at all. We're trying to find V here. Okay, I'm going to put in what we know. We know mu, we know G, looking for V, and R in the question is 50 meters. Okay, follow me over here. So if I multiply everything and then take the square root, I will get the maximum speed that you can take this corner with. Okay, and I get a value of 17.2 meters per second. Okay. Now I want to see what happens if the pavement's wet and the coefficient of friction is significantly lower. Okay, it's half of what it was before. Okay, the math's going to be exactly the same, but let's see what happens here. I'll write it out. Now mu is 0.3. I'm going a little bit faster just because all of these steps are identical. Okay, so again, if I multiply everything, take the square root, I'm going to get an answer of 12.1 meters per second. All right, just to give you an idea, that is about 44 kilometers per hour. Okay, so you certainly wouldn't want to go faster than that, probably even when it's dry. Let's discuss what happens if you do go faster than that value we just calculated. So what I'm going to just draw is, imagine it's a road. Okay, this is the path the road takes. The curve itself has a radius of 50 meters. Okay, so there's an amount of friction between the tires on the road, and the friction can provide a set amount of force that turns into centripetal when you're turning, mv squared over r. All right. If you're going faster than this 12.1 meters per second when it's wet, the friction can't provide enough centripetal force to follow this path. So friction is less than this value. All right. Which can mean a couple of things. To decrease the amount of centripetal force required, you could decrease your mass, but remember that would also decrease your friction, so I don't want you to think about mass at all. To decrease centripetal force here, you could decrease your speed, which would make a lot more sense. But if it's too late for that, physics is going to make you take a larger radius turn. Okay, so with the amount of friction available to you, if you're going faster than the value we calculated, this path where the road is impossible. There's not enough force for you to follow this path. Okay, in order to follow that path, you might need to, I don't know, have a rope attached to a post in the middle, some kind of magnet situation. What's more likely though is the universe is going to tell you, you need to decrease the centripetal force. One way of doing that is to have a larger radius. So this is the road. The universe is going to make you take this path, which is probably the ditch, or even more likely your car rolling over. I hope that makes a bit more sense.